right, let's go ahead and continue on here. What we've gone over so far with OSPF, let's look at these two examples. We've gone over where the PE to CE routing, we're using the same process ID. So we're using the same process ID. That means that the domain ID will be the same between 3 and 6, which infers that essentially your backbone, this becomes essentially a big area 0. This is your super backbone here. So this is essentially your OSPF area 0 here. The routes learned from this area 0 go to this area 0 and go out to this area 0 here as inter-area routes. So as inter-area routes, because the process IDs were the same and the domain IDs were the same. Now, when we change the domain ID, so when we change the domain ID on R6, it essentially said that this is not one big super backbone anymore. So this is not one big area 0 here. So what happens is the routes essentially, it's like getting passed from one OSPF process to another OSPF process. So essentially routes going across the implicit VPN will show up as external. So the first option we saw was they were inter-area. The other option was they were external. Now what we're going to see is we're going to make them intra-area. And when I mean intra-area, the routes that are originally intra-area, they're going to remain intra-area. The routes that are external will always remain external no matter what. The routes that are inter-area will always remain inter-area unless the domain IDs don't match. Then they get bumped up to external. So you can make it from intra-area to inter-area, and inter-area to external, but you can't go backwards. You can't say, I'll make an external inter-area, or I'll make an inter-area intra-area. It's only backwards in the path of the preferred route selection for OSPF. So you can take intra-area routes and make them inter-area, depending on how you have that backbone configured. You could make them external. You could leave them as intra-area routes. All right. So let's look at the issue real quick on the routes. Let me share this out. Share out my screen real quick here, and okay. Now we have this. We also have this backdoor link in place here. What I'm going to do is, because of the cost, that backdoor link is 100 meg. I'm just going to bump it down to 10 meg so that it essentially have OSPF treated as 10 megs, so that I can prefer the MPLS VPN. I don't want everything to have a cost of 1, and then I don't get the desired path through the network here. So I'm going to go and okay, now they're up. Same thing on the other side. And okay. All right, so the routes now are not showing up as with the cost of like 2 or 1 there. Okay. So what we're going to do is we're going to create the OSPF sham link here. What we need to do is we need a way to tie it between the two routers. So what we're going to do is we're going to create a new loopback on R3 and R6. So we're going to create a new loopback, and what we're going to do is, with creating that new loopback, what we're going to do is put it in the VRF, and that's what we're going to tie the sham link to. Okay, we're also going to need to pass that into the BGP also, so it's learned across. Interface, loopback, let's just say 36, IP VRF forwarding B, and IP address, just do 36.36.36.3. Okay, and I'm going to do the same thing on the other side here. And you can think of these are like the anchors for that sham link. Okay, so these are the anchors for that sham link, because you don't have any interfaces that are not already within without already within OSPF that are in that VRF, right? I mean, because the interfaces we have now, they're connected through to the CE routers, and they're running OSPF. So I don't really want to anchor it off there. I want to create these loopbacks and then anchor the sham link off of these loopbacks here. IP VRF forwarding B. Oh, I'm going to the loopback. IP address 36.36.36.6. And now let me go router BGP 200, address family IPv4, VRFB, redistribute connected. So I can bring in that loopback. And let me go also under 3, do the same thing. Router BGP 200, address family IPv4 VRFB, and redistribute connected. Show IP BGP VPN4 all. And there are the loopbacks there. So those are the loopbacks there. Okay. So once that part is done, I'm going to go ahead and do my sham link here. And let's go. Actually, I could have started on 3. Router OSPF 100 VRFB, area 0, sham link, specify the IP address here, the source. Source is going to be 36.36.36.3. Wants to know the destination, 36.36.36.6. And it wants to know if we want to associate any cost. I'm going to leave the cost to 0. Okay, if I don't put a cost on, it'll be 0 there. And let's go back to 6. Router OSPF 100 VRFB, area 0, sham link 36.36.36.6, 36.36.36.3. All right. So now that we can see that it's up here. Show IP OSPF sham links here. So I can see it's up. It's just, it's the output of this command is like the output of the show IP OSPF virtual link. Very similar. We have an adjacency state. It's run as a demand circuit. It's very similar to a virtual link here. All right. Oh, let's go back here and look at the routes. Show IP route VRFB. And let's see what routes we have here. We have this OSPF route here. That was the additional. This is from 3. So that OSPF route's from 3 here. And you can see it is, this route here is intra area. Let's go on to 8 and see what 8 shows here. So we can see here that to get to that loopback on 3, or to get to that Ethernet interface on 3 there, that it prefers to go to 6. Still prefers to go to 7. Okay, go directly to 7 for that loopback across the back door. To get to the loopback on 7 here, it is preferring to go across that back door there. But the routes that are inter area can be learned across the MPLS VPN and remain, sorry, not intra area. They can be learned across the MPLS VPN and remain intra area, and that's what we wanted. So now OSPF is just, OSPF is preferring the cost of that link there. I can go change that. Of course, we can go change that cost of that link. See what we prefer here. Okay, so now it's preferring this here. All right. So the options we have with OSPF. Let's fall back real quick and look at the config. Let's walk through the steps we did. The first thing we did on each router is we created an anchor interface, essentially. This is an interface that we're going to run. The source it's going to be the source and destination for the sham link on each router here. Once we did that, we're going to redistribute it in. So show run into BGP, so it's advertised to the remote device. Show run interface 36. LO 36. So we did this on both sides. Unique IP address, obviously. Once that was done, we redistributed it into BGP, into the VRF, so that it would be advertised across. So once it was advertised across, what we did is brought up the actual sham link itself. So once it was advertised across, and that's all we did right there. Area 0 sham link, and then specified it here. And obviously, we chose area 0 for the sham link because the PE to CE routing, that area is also area 0. If it was area 1, we would specify an area 1 sham link there. But because it's area 0, that's what we're running with the CEs. That's what we wanted to put here. All right. The verification, it works. The verification, it works. Show IP OSPF sham links. Okay, and it looks just like the output of a virtual link there. The question was brought up here, can a sham link run between 2 different areas if the CEs are, say, in area 1? You can, but you really don't get, you won't get the advantage of intra-area routes remaining as intra-area routes. So that there really wouldn't be too much advantage to that there. You might as well just run the standard OSPF, quote-unquote, super backbone there. Okay, So the three ways we saw here, let me flip back to the slides here. Three options we saw. Have the routes show up as external, have the routes show up as inter-area, have them show up as intra-area there. All right. So this sham link essentially enables us to tie that area together. So it ties that area together. So if we're, if we got, OSPF area 0 running on the VPN sites, it allows us to tie that together is what it does. And exactly what it says here. Sham link is essentially a virtual link. All right, and it lets us preserve all the normal routes in what they normally are, rather than alter them to inter-area or alter them to external routes. All right, so there's the config we did basically. The biggest thing you want to remember is you want to advertise that in. You need to create that anchor. You need to create that anchor and then advertise it in. So create an anchor and advertise it in there. I just did redistribute connected because that's easier. You could have also done a network statement under there. It's just a BGP peering session, basically here. Sorry, not a BGP, it's a normal BGP process. You could redistribute in, you could have done a network statement, whatever you wanted to do there. Of course, the only drawback of redistribute connected is you could possibly bring in extra interfaces you really don't mean to bring in. All right, but they have to be within that VRF to begin with. So usually not a problem when you're doing MPLS VPNs to do redistribute connected, because you don't have, most interfaces that you are redistributing in to connected are ones you want to advertise anyways. All right. So that's the example we did here. And the biggest thing is we want, those VPN sites to route across the MPLS VPN. There was a question, says, is it okay to advertise a loop exit? Yeah, it really doesn't matter if you advertise them to those, the other routers there. So what's going to happen, as soon as you pass it into BGP and it gets advertised across, it ends up getting passed in. If we looked on R7 and R8, those anchor interfaces we created were learned by the other devices, and that's fine. Okay. So this is more of a common type of scenario, meaning that you're providing MPLS VPN services for a client, but that client wants to ensure that if the MPLS VPN goes down, that it can use its backdoor link. You could flip this around backwards, where they want to use their link between them as their primary, and then they want to use the MPLS VPN as the backup. So that's an option to, not a very common option, but it is a potential option to be aware of there. An example of this, maybe they're doing a new implementation of this service, MPLS VPN services, and they're not really sure if this is what they're going to eventually go to. So you may have to get in here and flip this around backwards, make them all external. So just go on to the PE routers, make the domain IDs different. If you're using the same process IDs, make the domain IDs different, just so that all the routes are external. And all the routes are external. This will be the path that they would choose last, because if they're learning about internal routes, inter-area and intra-area routes out here, they're not going to go across MPLS VPN for those externals. But if they lose the inter-area or intra-area routes, then they will flip over to the externals there. All right, so it could be backwards from what you commonly see. You know, this like the scenario we just showed here. We could flip this around backwards, saying always use the backdoor link, never use the input VPN unless the backdoor link is down. Then I guess it's technically not a backdoor, is it? It's a front door. That'd be a funny lab. Always use the front door link. All right. Okay, so notes here. Let's go through these here. So if the P router's OSPF process ID do not match, so if the process IDs of the P routers do not match, the intra-area routes learned via the super backbone will be external type 2. So if your process IDs are different, they're going to be external type 2. These are the kind of things when you're going through the workbook and you're going through the workbook labs, as soon as you start seeing, you use OSPF as a P to C protocol on this router and on this router, use the process ID of 100 on this router and 200 on that router. You immediately know, all right, these are going to be external routes. If the P router's OSPF processes do match, or the process IDs do not match, but the domain IDs do match, the inter-area routes will be learned via inter-area. Kind of a tongue twisted there. So the key is basically the domain ID. This is the key. If the domain ID, okay, is the key. So the sham link, by default, that sham link had a cost of 0 when we put it on here, so it is preferred here. As a side note, like I mentioned, OSPF externals will always be OSPF externals. There's nothing you can do about that. All right. So those are the configs that relate to OSPF. The only one that was, any sort of different than we saw before was the sham link. Everything else was the exact same we saw for RIP or EIGRP. The difference is how the routes were learned across came to the domain ID, which is based off of the process ID by default if it's not hard-coded in there. So that was the only difference that we saw in the behavior, but the functionality and the configuration is very similar. The sham link was the one that was totally different there. So the sham link was the one that was totally different. Someone had a good question. They said, so the sham link will stop the use of the backdoor link, and that were correct. The ID, if you make the cost 0, theoretically, they're going to prefer the sham link. But you have to take into account also the cost between the CE and PE on both routers. You have to take that into account against the cost of the directly connected link. That's why I bumped it up, so that they didn't prefer, because the cost of directly connected link between the two routers, the backdoor link, was more preferred if I left it at 100 megs. And one more question here. It says, how do we differentiate between the process and the domain ID? It's up to you. If the process IDs are different, but you want the devices not to treat all routes as external, then you manually set the domain ID. Okay. Normally, in the scenario you deal in the real world, you don't have to worry about that. You just use whatever process ID the customer is using. Now, you could run into a case where the customer is using the same process ID that you're using, so you need to change it, and then you need to hard code the domain ID. But if you have the freedom to do whatever changes you want, then you'll just make sure your process ID matches what the customer is doing. But in the real world, your process ID may be the same thing that the customer is using. So then you just go and set the domain ID. All right. So let's go on to BGP. We're going to talk about 3 things with BGP as far as PE to CE routing is concerned. In this example here, in this example here, we'll see that we can have some potential problems. BB1 sends a route, a prefix, I should say, up to R6. R6 sends it across, input this VPN to 3. Now 3 sends it down to BB3. This is going to create a problem. The problem that it creates is BGP's loop prevention mechanism says when I receive a prefix, I look at the AS path information. If my AS path is in there, I will not accept that route. Okay, so I will not accept that route. That's how BGP does loop prevention. But now in this case, because we are providing MPLS VPN services, we need BB3 to accept that route. We don't want it to go through its standard loop prevention mechanism of checking the AS path and then dropping it because it sees that 54 is already in the AS path for that prefix. So what we're going to do is a real simple command. We're just going to go and configure the AS override feature. What the AS override feature does, and for this simple example here, we'll go on to 3, we'll put it on the neighbor going to BB3, and what we'll say is to override the AS, meaning that if I'm sending an update to AS54, what I'm going to do, I'm going to look at that update, that prefix, and I'm going to see is AS54 in the path. If AS54 is in the path, I'm going to remove it and put my own AS in there. So what's going to happen is the route that comes from BB1 to R6 to R3 will not have AS54 in the path. It'll have AS200 in the path. The AS54 will be replaced with AS200. Because as you can see, this wouldn't work any other way, right? I mean, this wouldn't work any other way. Now, there is one way we can make it work. We go into the CE router, and we'll look at that feature next. But in this case here, if we want the route to be sent down, we're going to have to override its AS number in the AS path for that prefix. So what we'll do for the first scenario here to test this, the simplest way, let's bring down the backdoor link. So now what we have is we have R7 in AS100, R8 in AS100, and then we have R6 and R3 in AS200. So what we're going to need to do is we're going to need to get routes from R8 to R6 over to R3, which isn't a problem, but we're going to need to get those down to R7. By default, R7 will drop them because it sees AS100 in the path. All right, so let's switch this over here. Let me share out my window real quick. Okay, so we're not going to use OSPF now. So no router OSPF 100. I'm going to shut down that link. Link is shut down. Go to 7, do the same thing as far as removing the process. Okay. No router OSPF 100. 3. Let's go back to 3 real quick here. And no router OSPF 100 VRFB. And we're going to do the same thing on the other router here. Let me do a show run again. Let's look at the whole BGP process real quick. Sometimes it leaves some of the redistribution commands on and so forth here. So let me look at it for VRF. It's got redistribute connected and redistribute EIGRP in here, and we couldn't get rid of that redistribute EIGRP. Well, one way we could get rid of this, let's see, router, just trying to clean this config up before we move on here. 200, take off the redistribute connected. Yeah, didn't like this one. And I don't think it took it out, though. One way to get rid of that, and just in case you wanted to know, would be to remove the VRF from the router. It's going to, of course, remove this config here. All right, we're not going to worry about it. It doesn't seem to be interfering with anything. Router OSPF, no, 100 VRF B. That got rid of that. Okay. Let me go remove the redistribute connected. And no redistribute connected. Now what we're going to do here is we're going to peer BGP. So neighbor, this is R6 peering with R8. Remote AS 100. We'll go to 3, do the same thing, we'll peer with 7. And neighbor 10.1.37.7, remote AS 100. Okay, and I'm going to go down to 7, router BGP 100, neighbor 10.1.37.3, remote AS 200. And let's go here. Router BGP 100, neighbor 6, remote AS 200. Show IP BGP summary. Okay, now it came up. Okay, so it's up. Let me advertise some networks here. So we have some routes here. Router BGP 100, network 7.7.7.7, mask, network 10.1.7.7. And let's go to 6, show IP route VRF B. Do this here. Should have did it here. All right. And let's go down to 6 here, see if we have any routes in the routing table yet. Don't have any routes yet. Nothing in here. The summary here. So I have the neighbors up. Let's just do a you know what? I think I did. I think I put them on the wrong router real quick. Pretty sure I did here. I was thinking about moving over to router 7 as soon as I'm done with this. And I think I put the wrong network statement on, which I did. I was close. I was only one router away. Just put them on the wrong network statement. There, and network 8.8 mask. All right. Put any prefixes from the device yet? Well, while I configure R7, I'll just do a clear IP BGP star. Go to 7 real quick here. Neighbor 10.1.37.3 remote AS 200. Already have it on anyways. Network 7.7.7.7 mask. And network 10.1.7.7. All right. I have them. All right, just took a second. And there they are. All right, it should be in the routing table. They are. So I have the routes learned from AS100. Let's see what Rudder sees. R8 should not see the routes from R7, and R7 should not see the routes from R8. And I don't have any routes here. And the reason I don't have any routes, obviously, is because they are in the same AS. So they're not going to accept those routes. Okay, so now what we want to do to solve this problem, so we have VPN sites, they are the same AS number, and I need to send down the I need to manipulate the AS path when I send down the prefixes so that it doesn't see itself in the AS path. Okay, so let's go up to 6. The router BGP 200. And neighbor 10.1.68.8. And what I want to specify here is AS override. All right, and you can see it cleared the neighbor for us here. And then now I have the routes. As you can see here, what it did is it found AS100 in the path, and it replaced it with itself. So it whatever it found AS100 in the path, it replaced it. It said, I've got this neighbor relationship with this peering relationship, I should say, with a router in AS100, and I have the command configured on here that says AS override. So since that peer is in AS100, whenever I send any prefixes to it, I'm going to look to see if AS100 is in the path anywhere. If AS100 is in the path, I'm going to remove it and replace it with my own AS. All right, doesn't solve the problem with R7 here yet, because R3 is not configured for this yet. All right, but we'll look at another feature to solve this issue here. Let's switch back to the whiteboard here. Okay, before we switch out of this here, should be this is actually slide is actually slightly wrong. This should say PE router AS override here. This feature is used on the PE router here, not the CE router. So just allows the learning prefix containing the local AS number in the AS path. Actually, sorry about that, guys. These two slides right here are swapped. This slide should actually be for this next feature, and this is the slide for. Sorry about that. They're titled wrong. The AS override. So overrides a eBGP peer router's AS number with the local router's AS number in the AS path for a prefix. This is exactly what we saw here. So it's not this slide is just got the wrong title on it there. Okay, so it's commonly used on the PE router, and that's exactly where we used it here. All right, let's look at the other option here. The other option would be to allow AS in. Oh, so the allow AS in. The allow AS in says if I see my path, my AS number in the AS path attribute for the prefix, I will allow it in. Okay, I understand I have this particular situation where I need to allow it in. So what we'll do here for this, and this is done on the CE router. The other one, what we did earlier, was done on the PE router. We wanted to override it before it ever got to R8. So rather than saying in the path, rather than saying when it was sent down 200 and then 100, what we did is we overwrote that 100 with our own AS number, put 200 in there. We're going to do this a little bit differently. We're going to allow it to be sent down to R7 in this in this example. But on R7, what we're going to do is we're going to say, okay, I know my AS path may possibly be in, for these certain prefixes that or the prefixes I'm receiving from this neighbor. So I'm going to go ahead and allow that to occur. As far as this backdoor link, it's really not used yet. The backdoor link's not used yet. We're going to use it in the next example. But for this example, it really doesn't. It really doesn't come into play. I mean, you could peer 7 and 8 together, and then you can look at the routing table to see if the route. Sorry, look at the BGP table to see if the routes are even being received by the by BGP. But we want them to actually show up in the routing table, so we can quickly verify them, rather than looking at the BGP table and filtering through and find out which ones it's using. So for simplicity's sake, for this case, I just leaving that off. I could have also done this example between, R6 and BB1, and between BB3 and R3. That could have done the example that way. It's not going to change anything if they're pairing with each other. It's just that they probably won't prefer it anyways, because the route through the route through the directly connected here peering session was probably the one they're going to prefer here. Okay, so let's go ahead and let me share out my screen real quick. Okay, so we're going to go here. We don't have any routes learned via BGP. Router BGP 100. Neighbor 10.1.37.3. Allow ASN. You can also specify the number of occurrences. You can specify the number of occurrences in the AS path. Okay. Clear IP, BGP, star. Let's just clear it. Let it come back up. There it goes there. So now it's allowing it in here. So now we are receiving the route. We essentially turned off the loop prevention mechanisms. Okay. All right, so pretty straightforward. We solved this problem two ways. We saw it, solved it, I should say, one using the AS override and one using the allow ASN there. All right. I didn't specify, someone asked a question, what's the default number of occurrences when you had that command? I didn't specify it, so it's not going to count. I'm not going to count how many occurrences that I want in it. I don't take that into consideration. Okay. Switch back to the whiteboard here. Like I mentioned, those slides, I'll update these at lunch. The slide title here, this should be for allow ASN, and this one over here should be for AS override. So they're just mixed up there, slide titles there. Okay. So real quick, if we summarize, we know what the problem is. The problem has got two possible solutions. The problem has two possible solutions. The problem is we can't send routes back into an AS when the AS path is listed in there for the prefixes. So we can't send it back in. Well, we can send it back in. The other side just doesn't listen to it. Just drops it. It thinks there's a loop out there somewhere. So there's two solutions. On the PE router, we can use the AS override feature, which is what we have here. We could use the AS override feature, which means find the occurrences of that AS path, that of the neighbor that I'm sending it to, find occurrences in the AS path, and then replace it with my own. Okay, so that's why on R8, when we looked at the routes from R7, the AS path was 200, 200, because we replaced it there. Okay. The other option was just to say, the other option was just to say, I know my AS path it may possibly be in these updates. So I know I'm using, I'm doing MPLS VPNs or whatever reason. I know my AS path may be in these updates, and I want to get in here and allow that to occur. Allow these prefixes to be learned if my AS number is in the AS path. So that's the reason on R7 when we looked at the routing table, the AS path said 200, 100. All right. There are two options to that solution. Obviously, when you're doing MPLS VPNs and you see you're using BGP as your PE to CE protocol, and you've got two sites and they've got the same AS number, you know you're going to have an issue. Okay, you know there's two ways of doing this. If you can get onto the CE router, you can allow AS in. If you want to make your changes on the PE router, you say AS override. They both do this. They're both solving the problem. They're just solving them in a little bit different way. All right. As a side note, really doesn't relate too much to our design or but really large scale networks though. If I allow the AS number in here and then R7 tries to go pass that on to a third party router, that third party router, or not third party router, but that third router, let's say R9, and it's in AS 100, it's going to drop it because it sees AS 100 in the path. So you'd have to go and do this, it could be a cascading effect. Okay, the solutions in the real world, if it's kind of designed like it is, where you've got a remote site, a VPN site, and there's one router there, and that router is running BGP. You can use BGP as your PE to CE protocol. You could do it either way. It doesn't really matter. But yet, if it's a VPN site and they're doing a lot of BGP peering internal to the VPN site, you probably want to use the AS override feature. You just want to go ahead and clean it up so that they don't have any problems further down the line. All right. Those two features you need to be aware of when you're doing MPLS VPNs and your protocol is BGP. Okay, and if you're not aware of them, when you get to any of the workbook labs and we're doing BGP as the PE to CE protocol, you're going to run into obviously some problems. All right. BGP site of origin. This is similar to the site of origin with EIGRP. Okay, this is similar to the site of origin with EIGRP. What we have is, what we want is, I should say, we don't want routes fed back to us. In EIGRP, we didn't want routes fed back to us because we didn't want this potential looping problem that may take a little bit of time to work itself out, to the hop count maximizes itself, and then eventually the route will be cleaned out. With BGP, we just want to stop. The potential behavior of sending a route into an AS, then that AS sending it right back to us. Okay, so we don't want that that potential problem to have. We don't want to have that potential problem. So we don't want to send a route to R7. R7 sends a route to R8, and then R8 sends it to R6, all through BGP. What we want to do here is on R6, we want to drop that route. Okay, we don't want to ever start to prefer that route over our peering session internal. Okay, and the way we do this is we use the site of origin attribute, the site of origin community, and then we're going to set this so that we don't allow these routes to get fed back to us. All right. Okay, so let me share up my desktop here real quick. Let's look at this in more detail. Very similar to the EIGRP site of origin. So used to prevent routing loops when dual-homed P to C routing is being used along with the AS override feature. So along with the AS override feature. So you could think of those CE routers. What if those CE routers did the AS override feature? What if you had this situation here where the what happens if it comes down to here? I guess the question is, say, should it be blocked by BGP by default? The problem is we could have R7 using the AS override peering to R3. So this is just another way to check it. So this is another way to check that route in case they are using AS override. You're going to see this when you go through the workbook. You're going to see some really obscure designs, and you're going to have to be aware of these types of solutions and how do you work around them. Okay, so let's look at the configuration real quick here. So first off, what we'll do is we will create the problem. So we will create the problem that we explained here, which is not easy to do, but we will do it here. This is what I mentioned earlier real quick about how the AS path looked different between the two, depending on the feature that we were using. See, one's using allow ASN and one's using AS override. 7's using allow ASN, R6 is using AS override. Now what I'm going to do, I'm going to bring up that peering session. I'm going to bring up that backdoor link so they peer with each other. So routes can come from 6 to 8 to 7 and then back up to 3. All right, so interface FA0/15, no shut. 10.1.78.7. See if I can ping across, and I can. All right, and the router BGP 100. 1.78.7. Remote AS 100. Back to 7 here. And 100. All right. It's up. But it's up, and I got 3 prefixes learned. I had 4 prefixes learned. I had 2 prefixes learned. Okay, so we have the route to the loopbacks learned via BGP directly from R8 there. Most of it configured here to look at. If this over here, if this device Over here was AS100. So BB1 was in AS100. And the route comes to 6, goes down across here, then also goes out through here. Then what's going to happen is, because 3 uses that route, through R7, 3 is going to advertise it across here. It's really not what we want. Okay, so that's really not what we want. So that third route is really what you need to bring up in AS100 to get the design to see the full effect of this issue here. But let's go ahead and do the configuration here. Let me show you what the configuration looks like real quick here before we actually do it. But this is what the configuration actually looks like here. So I'm just going to say router BGP under address family, and I'm going to say a route map inbound. And then I'm going to specify, this should actually be, why these slides didn't come out right? This should actually go to a new line, of course. So set in the community, so 3636. And what we're saying is if we receive any routes with this site of origin configured, this extended community for the site of origin configured, we're going to drop them. All right. Let's go to the routers, look at the configuration. All right, everybody should be able to see my screen here. Now, let's go ahead and configure this here. And what we can do here is create a route map. So we're going to create a route map, whatever you want to call it. And we're going to say set extended community, and then we're going to say whatever value we're going to use. And then router BGP 200. This here. And address family IPv4, VRFB, neighbor 10.1.37.7. And then what I want to do is I want to apply this route map inbound here. Let's go to 6 real quick here. Make the same route map. This is the exact same extended community. This is what we want to match on here. All right, and then we're going to specify under router BGP 200. Neighbor 10.1.68.8 route map, and specify the name of our route map here. Down here. Same thing over here. Let me clear this here. All right. So the configuration, you know, the idea is that you are just you're essentially just protecting yourself from the potential of relearning those routes back in here. And let me see here. Go back to 3 real quick, actually. Show IP route VPN. Sorry, show IP BGP. Routes, I got a hop of 7. Look at this one here. And we can see the extended community site of origin has been set there. So it'll stop us from, it'll stop this potential of sending routes out and being learned back in here. All right. You can also see the one from R6 has this set too. Right. It's also going to stop us from re-advertising this. Well, not stop us from re-advertising, but it stops those CE routers from re-advertising this to us. They'll send it to us, but we just filter it off. Because they could, in our case, we're not manipulating the AS path, in our case, on our CE routers. But if they had AS override, that would mean the route comes from 3, goes down, and then comes back. So if they're not doing AS override, the routes are not going to go from RAS to their AS and back to RAS. Okay, we would have to have they would have to have the AS override feature configured, or we would have to say allow AS in. One of the two there. The common one you see is AS override done. Okay. So the basic idea is that it's doing just some automatic filtering for us. That's what it's doing. So let's look at this one more time here. Let's go to the whiteboard real quick and walk through it. All right, let me clear this. Let's just readdress this one here. Let's say this is not AS54 and this is AS100. So this is AS100 here. AS100 on BB1 sends a route to BB6. Sorry, BB6. R6. R6 sends it down to R8. R8 sends it, sorry, R6 sends it across the MPLS VPN to R3. R8 sends it to 7. And 7 sends it to 3. Now, in order to get this route down, from AS100 to AS100, we had to override AS path. So the AS path looks like 200. It's like 200 here, 200 when it gets to R8. Now, it sends it across to R7 here. R7, let's say R7 had the AS override feature configured to override the AS numbers when anything that had AS number 200 when it was sent down to 200. So what happens is 200 now would be replaced with 100, would essentially be replaced with 100, 100. The site of origin attribute, extended community, what it'll do is, even if the AS path, even if it's okay to come in through the AS path, because we say that site of origin 33, the value 33 is set upon that route. So that particular prefix has that extended community set, the site of origin community set to 3636. We're going to drop it. So it's nothing that's going to happen by default. I mean, it's going to take a really big design to bring this problem up. Okay, it's not an easy scenario to create. You'll see it once or twice. Well, you see it probably 2 times in the workbook, but you can quickly pick out by, by it jumps out at you. All of a sudden, all these VPN sites have, they all have the same AS number, and some of them have backdoor connections between each other. All right. So it's something that it's definitely something to, to take into consideration. Though it's definitely something to take into consideration here. You could have another situation. Let's look at another situation real quick. Let's say I have this situation here, router, another router here. All right, these routers up here are in 1AS, say AS1. Router here is down here in AS2. All right, for whatever, this may be a VPN site you have, it's not easy to create. So it's not easy to create here. Let's say this is your network up here, and you're sending routes down to AS2. AS2 sends them up this way. You drop them because of the fact that your AS number is in the AS path. But if for whatever reason AS2, the router in AS2 has the AS override feature, the path will now be 2.2. Okay, so it just stops you. It doesn't necessarily need, it doesn't necessarily need a backdoor link to create its problem of itself if you're using the AS override. I mean, it could just be dual homed. We were dual homed through a backdoor link. Okay, so the router itself could be dual homed, or it could be, there's two routers, and one peers with one router in AS1 and one peers with another router in AS1. So two routers in AS2. So it could just possibly that they're dual homed. Anytime there's more than one connection coming out of that VPN site, you want to be aware of these potential problems once you start using features like AS override or allow ASN. So if you have a situation, if you have a scenario, if you have a situation where these guys do not have the backdoor link, it isn't a problem here. Okay, so there isn't a problem. No matter what, you can do AS override, allow ASN, you're not going to create any problems. But now if you become dual homed, say there's a link between 3 and 8, now you got the potential problem of routes coming in here, and then heading back up to 3. Yeah, I mean, it's just not going to happen on its own. BGP's loop prevention mechanism is going to work, and you're not going to have this problem. But as soon as you start, allowing prefixes in that have your AS in the path, or as soon as you have devices that are overriding the AS, your AS number in the AS path, you start to create these potential problems. So what we're going to do to guard against the loops, the potential loops that could exist, is we're going to use this site of origin feature. All right, and we're going to set this community, the site of origin community here, so that we don't accept them back in. So we're not going to rely on the AS path anymore for purely detecting routing loops. We're going to rely also on the site of origin extended community. All right. So, if we receive these, routes here, it stops us from putting it into our own VRF table, the VRF table for that site, and it stops us from being advertised to the CE. Okay. Okay, so now we're going to break for lunch here. Um, we're going to break for lunch here. We're going to move, for timing's sake, we're going to move internet access to Friday afternoon, because we still haven't gone over. We probably want to go over first inter-AS, MPLS VPNs, and carrier supporting carrier. So we're going to go over that this afternoon, and then on Friday afternoon we'll go over internet access. So we'll go over 4 different scenarios to provide internet access for MPLS VPNs on Friday. May even throw a 5th option in there, which is a variation of one of the existing options. Okay, so we'll go ahead and stop here. We'll go ahead and stop here for lunch, and then we will start back after lunch with inter-AS, MPLS VPNs, and then carrier supporting carrier. So let's break until noon, which is 45 minutes from now. So we'll start back at noon PST time, and then we will start with the topics for the afternoon.